Okay, good afternoon everyone. So this time we will tackle about topics in Mathematics 10, problems and solution in permutation, combination and probability. So we have this presentation will cover these three topics now: permutation, combination and probability. So this presentation usually it is in a form of problems, then also the solution. Okay, so let us have now problem number one. So this is permutations. So permutation is an arrangement of objects in a definite order. Okay, so that is the definition for this, the first problem of permutation. So we have here three items or three problems under this one. So evaluate the following. Letter A, permutation of 10, taking 6 at a time. Letter B, permutation of 13, taking 4 at a time. Letter C, a group of 16 people must select a president, vice president, a secretary, treasurer, and auditor. So in how many ways can this be done? Okay, so actually this permutation so talks about arrangement. Okay, so the concept actually for permutation is that we will have to use, of course, the concept in factorial, no? The n factorial. So some of the concept of the factorial method will be applied for this type of problem. Okay, let us have the solution for number one. Letter A rather. Permutation of 10 taking 6 at a time. So we have here 10 factorial over 10 minus 6 factorial. That is equal to, when we talk about factorial, so we are just going to multiply the numbers from highest going to its smallest. No? Example, 10 factorial, we have 10 times 9 times 8 and so on and so forth until 1. So the operation will be multiplication. In the denominator part, we have 10 minus 6 factorial, so it become 4 factorial. Simplifying, we get from the denominator part, we have 4 times 3 times 2 times 1. Then of course, because that is multiplication, so we can cancel out 4 times 3 times 2 times 1 from numerator and denominator. Okay, because they are common. So we have here that one. So cancelled out. Next is we will have to multiply 10 times 9 times 8 times 7. Okay, times 6 times 5. So the result will be 151,200. Okay. Solution for letter B, permutation of 13 taken 4 at a time is equal to 13 factorial over 13 minus 4 factorial. So same concept that we're going to have, same as in letter A. So we have to multiply 13 down to 1. So we have 13 times 12 times 11 and so on and so forth until 1. No? Then from denominator part, we have 13 minus 4 is 11 or 11 factorial. Simplifying from the denominator, we have 11 times 10 until times 1. Okay? So, of course, because still that is under multiplication, so we can cancel out from 11 to 1 from numerator and denominator. So, the remaining we have here, okay, of course, 13 times 12. So, we have 13 times 12 is equal to 156. Okay? We have here solution for letter C. A group of 16 people must select a president. So, 1 na siya. Second is vice president, 2. Secretary, 3. Treasurer, 4. And an auditor, 5. So, we have permutation of 16, taken 5 at a time. So, become 16 factorial over the quantity of 16 minus 5 factorial. Next to that, simplifying, same as in the process, same as the process in the previous slide or previous steps. So we have here 16 times 15, 2 times 1, and 11 times 10, 2 times 1. Okay? So, of course, we can cancel out from 11 to 1 from numerator and denominator. So, leaving us the quantities 16 times 15 times 14 times 13 times 12 become 524,160 ways. So there are a lot of ways, no, for us to select the president, vice president, a secretary, a treasurer, and an auditor. Okay, for problem number 2, this type of problem would be under combination. So we have here two items. Evaluate the following. So we have letter A, combination of 7, taken 2 at a time. Letter B, in how many ways can a committee of 3 be formed from a group of 10 members? So for this one, same as the concept in permutation, but it has something different from the permutation. Okay. So let us take a look for example number 1, or the solution for letter A. So we have combination of 7, take it 2 at a time, is equal to 7 factorial over 2 factorial times the quantity of 7 minus 2 factorial. So when we talk about 7 factorial, so we have to multiply 7 times 6 times 5 times 4 times 3 times 2 times 1 until 1. No? Then from the denominator part, we have 2 factorial. Then 7 minus 2 is 5 factorial. So at this time, we are not going to multiply 2 factorial times 5 factorial directly to give so that it would give us 10 factorial. That is not actually in that way. So all we have to do is simplify, or we have to rewrite this one in a form of multiplication. No? For 2 factorial, that is 2 times 1. 5 factorial is 5 times 4 times 3 until 1. Okay? So we have here, okay, from denominator part, 2 times 1, then times 5, times 4, times 3, times 2, times 1. We know that from the numerator, we have 5 times 4 until 1, or 5 factorial. And the denominator part also, it has 5 factorial, so we can cancel out. No? So leaving us 7 times 6, and from the denominator is 2 times 1. Okay? Then simplifying, we have 7 times 6 is equal to 42. Then 2 times 1 is 2, dividing 42 by 2 become 21. So letter A, the answer is 21. Then for letter B, we have here combination of 10, taking 3 at a time, because we are asked to identify, in how many ways can a committee of 3 be formed from a group of 10 members. So combination of 10, taking 3 at a time. So equivalently to 10 factorial over 3 factorial times the quantity of 10 minus 3 factorial. So simplifying, same as in the process of letter A. So we have 10 times 9 times 8 until times 1. From denominator part also, we have 3 factorial times 7 factorial, because 10 minus 3 is 7. Okay, simplifying, we have here from denominator part 3 times 2 times 1, then times 7 until times 1. Okay, so we can cancel out also 7 times 6 times 5 until 1 from numerator and denominator. So leaving us 10 times 8 at 10 times 9 times 8 over 3 times 2 times 1. Okay, so when we are going to simplify that one, 10 times 9 times 8 becomes 720. Then from the denominator, we have 3 times 2 times 1 is we have 6. Dividing 720 by 6 become 120. So that is the number of ways, okay, to select a committee of 3 from a group of 10 members. Okay, another problem we have here, this one is for probability, the first problem for the probability. Okay, a number is selected. Okay, a number is selected at random from the set of, we have 1, 2, 3, 4 until 20. So we are asked to find the probability of the following events. Letter A, drawing an odd number. Letter B, drawing an even number. Then for letter C, a number divisible by 3 or 5. So for letter A and B, of course that is under simple event, no? Then for letter C, drawing a number divisible by 3 or 5, we will be using the concept of LCM, no? So we know that the LCM of 3 and 5 is 15 because there is no common number between 3 and 5 rather than 15. No? Okay, let us have the solution for letter A. So, of course, because we have to use some variable that would represent this event, no, of obtaining an odd number. So we have let A be an event of drawing an odd number. So for letter A, because we are concerned with odd number, so from 1 to 20, there are only, we have 1, 3, 5, 7, 9, 11, 13, 15, 17, and 19. So counting them, that is actually 10. So we have 10 odd numbers from 1 to 20. So therefore, probability of A is equal to 10 over 20. So number of expected outcome and over total number of outcome. Okay? So we have 10 over 20 is equal to 0.5 or 50%. Okay? Then for letter B, an even number. So picking an even number from the numbers 1 to 20. So count. So we have here for the event, no, for letter B, we have 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. So these are the outcome for set B. So we have 10, no, 10 even numbers. Therefore, the probability of getting an even number, we have 10 over 20 because there are 10 numbers or even numbers from the numbers 1 to 20. So 10 out of 20 is 0.5 or 50%. Then let us have now the solution for letter C. Of course, for letter C, because we are asked to identify the number divisible by 3 or 5, so all we have to do is that we have to use the LCM. No? The LCM, okay, for 3 and 5. So of course, that is 15. So how do we use the LCM? We have 3, 6, 9, 12, 15. The first smaller number na common silang duwa, no? Ang for 5 pod, we have 5, 10, 15. So 15. The smallest common number between 3 or 3 and 5. So we have here, let C be an event that a number is divisible by 15. Okay, because that is common between 5 and 15. Using the concept of LCM. So therefore, C having an element only of 15. So therefore, probability of C is equal to 1 over 20 is equal to 0.05 or 5%. Okay, so let us now proceed to problem number 2. A jar contains 6 red balls, 5 green balls, and 4 blue balls. If a ball is chosen at random, find the probability of drawing letter A, a red ball, B, a blue ball, letter C, a green or a red ball. So for problem letter A and B, of course, that is under simple event. No? So that is very simple to identify. But for letter C, a green or a red ball, so we will have to use the addition rule of probability. Okay? So let us have the solution for letter A. Let A be an event of drawing a red ball. So we have, of course, there are only 6 red balls, no? Then the total balls, no? In all, we have 6 plus 5 plus 4, that is 15. So of course, probability of getting a red ball is 6 out of 15 or 0.4, or in percent, that is 40%. Okay? Solution for letter B rather letter B rather for the second one. Let B be an event of drawing a blue ball. So there are only, how many blue balls do we have? We have 4. Okay, we have 4. So of course in the set B we have only 4. Then of course in getting the probability of B, that is 4 out of 15, that is 0.26666 or 26.67%. Okay. For letter C, the solution for letter C, a green or a red ball. we have to use the addition rule of probability. So let C be an event of throwing a green ball and D be an event of throwing a red ball. So of course for C, we have for set C, we only have, because green man, we have 5, no? And for the event D is red ball, that is 6. So we have 5 and 6. Therefore, to get the probability of getting a green or a red ball, we have probability of C union D. Okay, union because that is under addition. So 5 over 15 plus 6 over 15 is equal to 11 over 15. Dividing 11 by 15, we get 0.7333 or 73.33%. Okay, so that is how to use addition rule of probability. No, particularly these two events are independent, meaning the first event would not affect the second event. Okay, so I hope that this will help you. This will guide you, particularly in answering your activity similar to these examples.